Hello everyone, I am Abhishek Verma and in this video I would be comparing the different memory mapping techniques used in the computer systems. In this video I would be covering the topics like what is memory mapping, its types like direct mapping, fully associative mapping, set associative mapping and applications of memory mapping, and then summarizing the difference between these three types of memory mapping techniques. Now, first let's see what is memory mapping. It is the process which is performed by the operating system to translate a virtual address to a physical address. Let's elaborate this statement. It means that a program has a virtual memory address to store data, and the data cannot be utilized until and unless this virtual address is converted to a physical address. So the OS is responsible for the conversion of this virtual address to a physical address, which can thus be used by the program to call the data and thus allowing the program to run anytime as soon as the OS loads it. Memory mapping is classified into three types: direct mapping, fully associative mapping, and set associative mapping. Now let's have a look at direct mapping. It is the simplest form of mapping in which the block of main memory is assigned to a block in the cache memory, also known as the cache line. And if the cache line is already filled with some previous data, the newer block will override, or we can say it will replace that data. And the tag field of the cache memory address, as seen here, is stored in the cache memory, while the rest is still stored in the main memory. In the diagram above, we see that the tag field of the main memory gets broken into two pieces: the tag and the line offset. The line offset represents the line number of the cache memory. The performance of direct mapping is directly proportional to the hit ratio, and the formula to calculate the cache line is I equals to j mod n, where n is the number of lines in our cache memory and j is the block number in the main memory, which gives us the value of which is the line number in or the cache line. The drawbacks of direct mapping is that it has a high chance of having conflict misses and is also very less flexible as compared to other memory mapping techniques. Now let's have a look at fully associative mapping. This mapping technique utilizes associative memory. The associative memory is optimized to perform searching operations. It stores patterns, and when a pattern is requested to the associative memory, it searches through the data stored in it and returns with a pattern which is identical or nearly equal to the requested pattern. Thus, this type of mapping using the associative memory is very fast and flexible. And in fully associative mapping, we are enabling any block to go into any cache line. It means that unlike direct mapping, the block is stored in a specific line. It would be directly filled into any free block which would be available. This also increases the amount of conflict misses, since suppose the block is stored in first line 0, then assuming that it is already filled, then it will check for line 1 and so on until it find an empty block to store the data. And other drawbacks such as the cost and power consumption and increased hardware complexity. Since this mapping is using associative memory, the number of transistors used increases, which increases the overall hardware complexity of our devices. and which also results in the increased cost and thus is not scalable. At lower levels means a smaller cache like the level 1 cache, fully associative mapping can be efficiently used. While in the rest of fields, it is not generally used. The physical address of fully associative mapping is uh, of the form as seen here, the tag and the word offset. The tag is again stored in the cache memory. Now let's have a look at set associative mapping. It is the enhanced form of both direct mapping and fully associative mapping since it uses the best from both. Instead of having exactly one line that a block can map to in the cache, in set associative mapping, we are grouping a few lines of the cache memory to make a set. And the block from the main memory is assigned a set in which, following the principles of fully associative mapping, any free cache line would be filled with the incoming data. The drawbacks of set associative mapping is its increased cost and complexity, since it reduces the disadvantages of both direct mapping and fully associative mapping. It gets slower and has a smaller cache hit rate as compared to other forms of mapping. Now let's have a look at the way mapping is done in set associative mapping using the example of two-way set associative mapping. The formula I equals to j mod m is used to calculate the set number in which the block would be stored in. The m represents the number of sets available while j represents the memory block number as found from the main memory. This formula gives us the value of I, which is the set number in which this block would be filled into. So let's say block J is filled into set M. And suppose if the line M is already filled with some data, it would be a conflict miss and this would be filled into this block here. If we wish to find the number of cache lines available, the formula n equals to m into k can be used where k is the number of lines per set. And in two-way set associative mapping, k is equals to 2. In this diagram here, we can see the structure of the cache memory address. From the main memory, the tag is again divided into two parts, a tag and the set offset. The set offset is representing the set number assigned to that block. Now let's have a look at the applications of memory mapping. Direct mapping generally used in CPU cache and embedded systems, while fully associative mapping having limited uses is generally used in networking devices due to its use of content addressable memory or also known as associative. Database buffer caches also utilize the fully associative mapping while set associative mapping having a complex task is used in GPU texture cache and web server caching, which are complex tasks as compared to other mapping techniques. In the end, it can be concluded that direct mapping, though is simple, leads to frequent cache conflicts, while associative mapping, utilizing the associative memory, eliminates these conflicts but is more complex and expensive as compared to direct mapping. Set associative mapping utilizes the strengths of both direct and associative mapping and in the end reduces the disadvantages of both. But this results in an increased complexity and reduces the cache hit ratio of associative mapping. Thank you.